Everyone. Welcome to Module 7. And as it says, this is the big one. This is indeed the big project. And, we're going to do a thermostat. And before we launch into showing you that, let's take a look at what you have for deliverables. This module. Basically, it's submit the final project and complete the quiz. Now you have a quiz. I believe you have some questions, sort of a report to make to it. Odd, it doesn't mention that here. Let's go on to the next thing. Project submission. I think it's part of your project. That's why it doesn't mention it. But anyway, I recommend before you do the quiz, you do the report, because you've got to do a lot of research, and that should help you with the quiz. And always remember, though, with those quizzes, you get more than one attempt. But the more upfront studying you do, such as researching the topics for your report, the better you'll do. And so we have some directions here. Let's take a look. You've got to read this lab guide. Now, a lot of this work for this module, you did it in your first GPIO project. So you've got a lot of the infrastructure in place, and the more modular you made your code, then the better off you'll be, because you can reuse a lot of code as is. Not all of it. And of course, you're losing one of the LEDs. Make sure you get the right one. I think in my case it was the green one. The temperature sensor and the green LED. Apparently, the pins for those two peripherals are multiplexed, and so I think you can only use one at a time. So since we're using the temperature sensor, you're going to lose the green LED. But I believe, and I'm looking at it right now, it appears to stay on all the time because you're reading the temperature sensor. It has that green LED lit. But I don't think you're going to be able to control it. So we're going to use the red LED. If your board's like mine, one or the other. The one you didn't lose, we're going to use it to turn on when the heat is on. So this should all look familiar to you. I won't go through that. Let's take a look then at this is the running code for the thermostat. Now, if you read the requirements, it's every second you're supposed to display from left to right here. That's the ambient temperature, the room temperature as read from the temperature sensor, the set point temperature or desired temperature, a flag indicating whether or not the heat is on. And here you see it would not be, because the ambient temperature and the set point are equal. And then finally on the right, the number of seconds accumulated. See that number grows by 1 every time. The number of seconds since the board was last loaded, reset. So this is 887 seconds since I started this code. Okay, then we have the buttons here, and I forgot which one is. One of the buttons I have programmed to reduce the set point by 1 degree Celsius. The other one increases the set point or desired temperature by 1 degree Celsius. So let's click it. Okay, set point decreased to 21. Okay, let's click the other one. Set point increased to 22. Now notice there's a little bit of a lag after I click the button. That is because in the specifications for this project, it asks us to check the state of the buttons every 200 milliseconds, I believe. So there's got to be a little bit of a delay. Now I'm going to hit it again. I increased it to 23. Now notice because I don't know if you noticed, but when I picked up the board, even though I don't have my fingers on the temperature sensor, just the fact that I picked up the board, the warmth, I suppose, from my hands raised the ambient temperature as read by the temperature sensor on the board by 1 degree Celsius. So I'm going to raise the set point, and notice now the red light is on, and we're getting a 1. I can't point with my finger. We're getting a 1 up here for the temperature state. And now I went back down to 0 because the ambient temperature increased. So let me click it again, turn it back on. Now we raised the set point so the temperature comes back on. Now I'm going to put my finger on the temperature sensor and see if I can raise it. So it raised it 2 degrees Celsius already, so the heat went off. Now I'm going to release it. You'll see the ambient temperature start to drop, and when it goes below the set point, if it does, the heat will come back on. And it did. It dropped below the set point, and the heat came back on. Now let's do one more. Let's turn the heat off by lowering the set point, and now it's off. So that's the goal. That's the task. Let's see how we do that. Okay, now I'm going to give you a good set of starter code, and it's going to have all of these method declarations. Now notice if I hover over these, it shows you what's in the method down below. But this is a pretty good idea because, yeah, I would even say it's a best practice, because if you may have noticed this also, but if you were to start rearranging your methods, let's say you wanted to put them in alphabetical order or something, and so you're calling something up in one of your top methods that hasn't been defined yet, because it's defined down below. If you don't have these method declarations up here, the compiler is going to complain that it's an undeclared method. So I would just go ahead and also it's a sort of a good way to plan and a good way to see Okay, have I over-engineered this thing or what? Um, and that way you can see at a glance everything that you have, and the compiler is happy. So I'm going to give you some great starter code with all of this in it, except some of these methods I will have replaced the code inside with some well annotated to-do suggestions. But you're going to see the code in this video, so that should help. So I have the timer callback, and all I'm doing is setting the timer flag to 1. And if you recall from our previous project with GPIO and the timer, where is it? Set timer period. In here I encapsulated almost everything you need about the timer. So when you call set timer period, it's not going to return until this timer callback sets the flag back to 1. So in set timer period, the first thing we're going to do is stop the timer, set the timer flag to 0, set the timer period using the handle timer 0, and we're going to pass in the duration. So we can use this for any duration we want. And if you recall, the goal, the specification said to check the buttons every 20 milliseconds, and then every half a second, we're supposed to read the temperature and update the state. And then every 1 second, we send a message out to the server, which in our case is the terminal. We're just, and I named the method send state to UART because that's all we really need to know about inside this code, I believe, is where we're just sending it through the UART out to the world. So in this case, it's coming back in from the board through the USB port, and we're showing it in the terminal. Now, I'm working on a Mac here, so my terminal setup's a little different, but here this says debug. Well, I've already got this terminal hooked up to, anyway, if you are working on a Mac, you can go into the, open up a terminal window, not a terminal window inside Code Composer, but let's see. In here, and you can list dev tty dot asterisk all of your serial ports, and so you want one of these that references the USB, and I believe it's this one. This one has a lot of other activity coming and going from the board, but this one is the one that I've been using for the terminal display of the output through the UART. So make sure you get your terminal pointed to the proper serial port. If you're on a Windows machine, it's the instructions are pretty clear in the assignment. And by the way, I'm gonna, like I said, I'm gonna give you some more starter code, but the code that's in the assignment is pretty old. If you notice here, we're using UART2, and I'm sure that all of you are, because we're using a much newer SDK, software development kit, than these original instructions assumed. So if you try to work with the starter code that's given in the assignment, you're going to have a lot of problems. So definitely use the starter code that I'm going to give you in the announcement. And it's a little more robust anyway. So let's take a look at some more of these. Let's take a look at the main thread. So every 200 milliseconds, we're going to check the buttons. So inside our perpetual loop here, we're going to set the timer period to the temp check interval, and that is wrong. That should be So we're going to get to see a little reprogramming here. Temp check interval. No wonder I thought that was a bigger lag than I would have expected. So the first one needs to be the button check interval. Then the temp check interval needs to be 3, because we want those to add up to half a second, and then we're going to take it the rest of the half a second with this. Okay, so let's rebuild. Okay, I'm going to disconnect first. I've unplugged the board from the USB port. I'm going to plug it back in. Now I'm going to build. And I don't see any feedback. Okay, and I know a lot of you have been seeing these messages. It's annoying, but just unplug the board. Oh. Unplug the board. plug it back in and retry. Okay, now we're going to have to restart our terminal. I'm going to set it to the wrong one first just to shock it back into awareness. I'm going to change it to the right one. And here is our stuff. Now the net result may look the same in terms of timing, but notice our number of seconds has reset. So now it's been running for 43 seconds. Set point. So notice there's not as big a lag from when I click the button to change the set point. It's more almost immediate that you see the results here. So I'm going to click the button. Before there was a half-second delay. Now there's a 200 millisecond delay. So it now follows specifications better. So that's the first thing. Inside the perpetual loop, we're going to set the timer period. We're going to check the buttons. So you see, as a result of that, when you remember in set timer period, it's not going to return control back to here, so that it's not going to call this next method until the timer expires. So it's going to wait 200 milliseconds after it calls this, and then it's going to check the buttons. So after we do that, then we're going to set the timer period for the temp check interval, which is 300 milliseconds. And if you recall, these these numbers have to be bigger than just 300 because of the way that we're doing it here. But you can play around with that until it looks right. But that's what will be in your starter code. So here we're going to wait. We've waited 200 milliseconds here. Then we're going to wait 300 more. Excuse me. 300 more milliseconds here. And then we're going to compare the ambient temperature to the set point, because after you check the buttons, the set point may be different. And inside this comparison, then we're going to go ahead and set the state. I've got all that encapsulated. Let's see. So inside here, we're going to read the temperature, and we're going to check if it's less than set point. We're going to set the temperature. We're going to turn the heat on, and if it's otherwise, we're going to turn the heat off. And then we're going to wait another half a second, and we're going to send the state to the UART. And I think even in your original starter code, it shows you how to do this. And so I'm going to leave all of this in place in that send state to UART. And that's what we're seeing rolling up here. It should be every second, and it looks like it. So all of these add up to 1 second. And so as a result, when you get down here, you can increment your seconds variable because this loop should run, it should take 1 second exactly to get to the bottom of this loop every time, and increment seconds. So in here now, I broke out a lot of the system initialization code into its own method just to keep this main thread clean, because this is your manager here, your scheduler. So you want to be able to look at this and tell right away what it's doing. So if you've got a lot of you see all this code in a init system. If you had all of that in your main thread, it would be harder to read. So I moved it up here, and I'll give you this. Now, one thing, when I was doing this yesterday, and my temperature sensor wasn't working, it was just not able to read the temperature. So it turns out this is what was missing. So I'm going to give you this in your code to allow the sensor to power on. A very critical piece of code. So I don't want you going through what I did yesterday, so I'm going to give you this. And you know, this is where we're just configuring our LEDs. And the buttons. And we're defining where the callbacks to the buttons are. So that's init system. And here's the comparison. We already saw this. I hovered over it, and you saw this. But this is all we're doing. We're calling read temp, and read temp is the starter code. Even the starter code from the original assignment contains all of the code for read temp. Of course, the read temp code that's in your original assignment may or may not work, but this one works. And so we're going to read the temperature, populate the value of the ambient temp variable with, I seeded it with 25. I guess I could have made it 0 and let it read, but you could do whatever you want. If you want to define it as 0 instead of 25, you could do that. Because as soon as you read the temperature, it's going to set it correctly anyway. So then we're comparing it to the set point. In the set point, I initialized it to 22. Again, you could... of course, the only way you can control increment or lower the set point is with those buttons. So you may not want to start it out as 0. You'll have a lot of button clicks to do to get it up to somewhere near the room temperature. So it looks like, as you can see here, I don't know, you may be in a colder climate, but here, the ambient temperature in the room I'm in is 23 degrees Celsius. So that's basically it. I'm going to give you the starter code Now, init timer, you did that already. There's nothing different here from what you did in your previous GPIO project. These buttons, these interrupt methods for the buttons are exactly the same as before. Um, so this code to check the buttons is new. I think before we were just going ahead and, um, if somebody clicked the button, we were immediately taking action. But here we just check the button from the main scheduler every 200 milliseconds. So this is new. And init timer is the same. These, you can just grab this from your previous work, how to turn the LEDs on and off. Now the difference here is it's a little simpler because before, when you were making the Morse code dots and dashes, you had to use the timer to set the duration of the LED. Here we're just going to turn it on or off, and that's it. Other processes are going to determine when it turns on and off again. So you don't have to worry about any kind of a duration when you turn the LEDs on here. And this may be over-engineering, but I like to keep things as atomic as possible. Set temp state on, set temp state off. But I'm going to give you all the method signatures up top, and then some of these I'll leave coded, some I won't. I mean, my goal is for everyone here to understand how to do this at the end, but I don't want you having to struggle too much. That there's a good balance, and we want to achieve that. Set timer period. This is exactly what I showed you for the previous project. So it encapsulates everything you need to do to set the timer and wait for it to expire. So you just call this with a duration, and then call your next method that you want to do at the end of that time period, and that should work for you. Send state to UART, that is included in the starter code because they already showed you how to do this. And by the way, I mentioned in my announcement for last module, Module 6, that when you started working on this, display wasn't working out for me, because I was using the original starter code. I had just sort of taken a quick stab at it, and so I recommended using some different technique for the display. But actually, when you get the right starter code, this works fine. So I would stick with this. And we've got a here's the definition of the display, and it looked right in the original starter code, but there were just so many other problems with that starter code. You couldn't tell what was actually causing it not to work, and it looked like it was this, but it wasn't. So here are those button intervals. So I think that this should get you going. Um, it's a fun project, and I hope you enjoy it. And I read everyone's um, discussion posts this past week. Responded to quite a few, and just you guys are really doing great. So thank you, and happy coding.